First period. So I would like to compute f of 2. Yay. You don't have to do this, right? You can already kind of envision doing this by hand is not a pleasurable experience, right? This is a bit of a pain. So let's see, that's 3 times 2 to the 5th minus 2 times 2 to the 4th minus 4 times 2 cubed plus 2 times 2 squared minus 5 times 2 plus 7. Yay. All right, that's 32 times 3, 96. 2 to the 4th is 16 times 2, which gives me minus 32. 8 times 4 is not minus another 32. That's 4 times 2, which gives me a plus 8, minus 10, and plus 7. All right, let's see. 96 minus that is going to give me 32. Plus 8 minus 10 plus 7, so 40 minus 10 is 30 plus 7 gives you 37. Right? So the goal today is not to teach you how to do this because you already know how to do this, and you probably don't want to do it anyway, right? But here's an interesting thing, right? And this I do want you to write down. So if I want to do synthetic division. So I'm going to put a 2 in the box, and I should change colors. I'll make this a 3, a -2, a -4, a 2, a -5, and a 7. And what I want everyone to do is do synthetic division. Let's see. Bring the 3 down. 3 times 2 is 6. That's going to give me a 4. That's 8. That gives me a 4. Well, that's 8. That gives me a 10. That's 20. That gives me a 15. That's 30. That gives me a 37.
What?
That's so awesome. It's not like how we can add. I'm smart. It's the same thing as you.
Oh, I'm glad we're thinking, right? Obviously, I don't just put random stuff on the board, right? I mean, I try to. So, any similarities between this and this?
The answers are the same.
Okay, so I like how y'all are focusing on the 37, right? All right, so right now you're looking at this saying, wait a minute, I got a 37 here, right? And when I did this big old mess, I got a 37 here, right? Just curious, would you rather do this, option A or option B?
B.
Yeah, unanimously option B, right? This is a whole lot nicer, right? Now, this is actually kind of cool because this is the first instant in math where we get the same answer by doing 2 completely different operations. Like, I think here you understand what's going on, right? You're plugging in, you don't like it, but you understand what's going on. You plug a 2 in, you figure this out, all this stuff out. And what's interesting is when you do synthetic division, whatever answer you get here is the same as if you plugged it in. Now, the proof for this is, if I have time, I'll talk about it. I probably won't have time today. The proof of it, the reason why that is actually kind of neat. But that's not the goal today. The goal today is to talk about how to compute. Like, if you've got some ugly polynomial, if I say what's f of 2, you could plug the 2 in, or you could do synthetic division. In fact, this is actually called, your book calls it synthetic substitution. Because you're substituting, like you're plugging a 2 in, but you're using synthetic division, and whatever answer you get here is the same as if you plugged it in. So notice how we got these things, right? So these are just the coefficients, and this number is whatever we put in here. All right, let's try it again.
Wait, so for this one, we don't change the sign of the divisor?
No.
Right? Okay.
Because technically we haven't talked about dividing. All we did is we did synthetic division. All right, so let's say that I give you f of x is equal to 2x cubed minus 3x squared minus 17x plus 30. And I want to know, what is f of -4? Okay, whatever this is -4. Are we okay with what goes here? It's just those coefficients, right? So that gives us 2, negative 3, negative 17, and a 30. All right. So go ahead and not terrible. Okay, bring the 2 down. This times this is going to give me negative 8, and that gives me negative 11. It's going to give me 44. It's going to give me 27. This times this gives me negative 108. And so I get negative 78. And so what does that mean? When I plug negative 4 in, what do I get?
Negative 78.
I get negative 78, right? I mean, that's what this means, right? When you do this, whatever answer you get for your remainder is the same as if you plug negative 4 in. And personally, I'd rather do this with the negative 4, right? I mean, could you plug negative 4 in here and like do negative 4 cubed, negative 4 squared, and add it all up? You could, right? It's going to give you the same answer, but this procedure is a little easier. Well, unfortunately, you know, I'm always not copying down the right number. I actually didn't want to know what f of negative 4 was. I wanted to know what's f of negative 3. So compute that. So we go through, we bring the 2 down. This times this gives me a negative 6, gives me negative 9. This times this gives me 27, which gives me a 10. This times this gives me a negative 30, and I get a remainder of 0. Okay? So that means f of negative 3 is 0, right? All right, now, this is where I need you to pay attention, because now we're about to go off the deep end in theory. Ready? Okay? All right, I need to make sure everybody's with me in theory. All right. This, okay. It's okay, I've just recorded. That'll be on YouTube. Okay, this, I want to model this problem. Like, when you did synthetic division a few weeks ago, right? I want to recreate the problem that would give me this answer, right? So imagine this is the work for synthetic division that you would have done 2 weeks ago, okay? So if this is the work you would have done for a synthetic division problem 2 weeks ago, what is the problem? What problem would you be given so that this is your work? It's a division problem, right? What would I divide this by? X plus 3. Is everybody okay?
Yeah.
Right? This synthetic division, right, this work for synthetic division started from like this divided by x plus 3, right? Like if I gave you this problem, this is what you would do, wouldn't it?
Yeah.
Right? This is huge. There's lots of little steps. I've got to make sure this step makes sense. Is everybody okay with this step? All right, what this means. So this synthetic division is, okay, it's modeling this thing. All right. So if this was the problem a couple of weeks ago, what's the answer?
2x squared minus 9x plus 10.
Perfect, right? Because isn't this our answer? And so this is telling me that if I do this thing divided by this, I'm going to get 2x squared minus 9x plus 10.
Why is it an x plus 3 again?
Because it's at the opposite.
Oh, so you just do the opposite.
Okay.
Okay. 0.
Remember, this has this, when you set this equal to 0, that gives you this thing.
Okay. Yeah.
All right, is everybody with me so far? See, I'm trying to connect some things we did a couple of weeks ago, and you know, there's a whole lot of stuff about to get connected. All right, we okay with this? All right, I need to erase this. I just need some board space. All right, before I start, so the topic for today, and actually the topic, and I want to try to connect what we're doing today, what we did yesterday. Yesterday, it was all about factoring, right? Yesterday was all about factoring. I gave you all sorts of weird things, and I said factor. Our goal for today, and actually in the near foreseeable future, is I'm going to give you a polynomial, and our job is to factor that polynomial. Okay? And yesterday we talked about things that had patterns, Like you were looking for certain patterns, and if you saw a certain pattern, oh, I can factor by grouping. That was the sum or difference of cubes. That was the difference of squares, right? You look for those patterns. Well, how do you factor things that don't have one of those patterns? All right? So what we're actually going to do is I want to factor 2x cubed minus 3x squared minus 17x plus 30. I want to factor that. Now, I'll go ahead and tell you what your answer is going to look like. First, what's the degree of this? 3. If it's degree 3, we're going to get 3 sets of parentheses. So when we're done with this problem, we're going to get 3 sets of parentheses. All right? Whatever your degree is, that's what you're going to, that's how many of these little things you're going to get. So when we're done, we're going to get this. Right? But as you found out, like yesterday, your problems, those were patterns. We don't really have a pattern, so what do you do? All right, here's what we're going to do. First, I want to talk about factoring numbers for a second. So let's say I ask you to factor 91. Okay, great, that's going to be on YouTube too. Okay, I want to factor 91. Now, most students don't know that 91 factors, right? It's some number times number. But what if I told you that 91 is going to factor as 7, one of the factors of 91 is 7? How would you find the other number?
Divided by 7.
You divide it by 7, right? We're back in elementary school, right? If I want to factor 91 and 7, we know 7's a factor, then we're going to do, okay, so 7 goes into 91 13 times. So if I wanted to factor 91, we're going to say, what's 91 factor as? 7 times 13, right? Everybody see how that works? Well, we're going to do the exact same thing, but we're going to do it with polynomials. See, when we did this division problem with synthetic division, we got 0 remainder, didn't we? Right? Because that 0 meant that it factored nicely. So, here's what I know. I know this. Here, I'll actually set it up this way. I'm going to say 91. I'm going to say 91 divided by 7 is equal to 13. Everybody okay with this? 91 divided by 7 is 13? And now let's look at their polynomial. We said this thing divided by x plus 3 is this thing. Right? So now I can say that this thing is equal to x plus 3 times what?
2x squared minus 7.
2x squared minus 9x plus 10. Right, does everybody see how that worked? You see it's the same thing we did with the number, isn't it? Like our goal was to factor 91, but we didn't know what 91 was. But I told you 7 was a factor. And so we divided 7 into 13, and we set 7 into 91, and we got 13. And so now we know that 7 times 13 is equal to 91. All right? My goal is to factor this thing in blue. We don't know how to do it. So I tell you x plus 3 is a factor. So we divided x plus 3 into this. And so we have this part, right? Now we're not done. Remember, I want 3 sets of parentheses. So now when I look at this, can I factor that? That's a quadratic. And if that's a quadratic, well, I think, well, how do I get 2x squared? Well, 2x and x. How do I get a 10? 5 and 2. Can I put the 2 here? No, because I could factor something out. So the 2 goes here, the 5 goes here. It's a positive 10 and that's negative, so I bet both of those are minus. Let's make sure I have the right answer. Does minus 5 minus 4 give me the minus 9? And then the x plus 3 comes down. And what we have just done is we have taken this thing and we have factored it. All right? Let's go over the steps again. Our goal was to factor this polynomial. Right? I need to give you a hint. Your hint is that x plus 3 is a factor. So then we take this polynomial divided by x plus 3, and we figure out what the other part is. Right? If you multiply these two things together, you get this. Now, once you get this part, now you can factor it. All right? If you're confused, that's okay. I have a few more examples. All right. So what if I give you x cubed minus 7x squared plus 7x plus 15? And our goal is to factor this, but I'm going to tell you that x minus 5 is a factor. What do I know one of the factors is going to be? X minus 5. How can I find what goes here? Divide. Right? Take this thing, divide it by this, using synthetic division, right? And that'll tell you what goes here. So do that. All right, now, if this is a factor, what should the remainder be? 0, right? Does everybody understand that? That's huge. All right, if I tell you this is a factor, that means when you do your synthetic division, you better get a 0 here. If you don't get a 0 here, one of two things happened. Either I messed up writing the numbers or you messed up computing, right? Right? Because if you don't get a 0 here, none of this works, right? So hopefully we get a 0. Bring down the 1, 5, -2, -10, -3. Yay, I got a 0. Okay? And so now what goes here?
X squared minus 2x minus 3.
X squared minus 2x minus 3. Does everybody see how that worked? Now you look at this and ask, well, can I factor that? It's a quadratic, you can factor it, so we're going to factor it. And that's going to factor as x minus 3 and x plus 1. Minus 3 plus 1 gives you -2. Remember that x minus 5? It's still here, and so end up with x minus 5. So my goal was start with this polynomial, right? And then when I'm done, I better, because it's degree 3, I better have 3 sets of parentheses. Does this make a little more sense than the last example? Right? This is huge, right? As some of you may think, well, this is kind of simple, right? Or what? But if you don't get this idea, everything else that I teach for the next 2 weeks is not going to make sense. Right? I have to make sure that this makes sense. All right, so let's try it one more time. What if I give you 12x cubed plus 28x squared minus 9x minus 10? Oh wait, sorry. I'm going to do that one later. I want to practice a bit more before I get to the crazy stuff. Let's do x cubed plus 4x squared minus 15x minus 18 and x minus 3. All right. So if I'm going to factor this, I know that x minus 3 is going to be one of the factors, right? I've got to divide, so I'm going to do this thing divided by this, and so synthetic division, I'll put a 3 in the box. And that's a 1, a 4, a -15, and -18. And 1 times 3 is 3, 7, 21, 6, 18, and I get 0. Good, I got 0, because if I didn't get 0, I have a problem. Then this is going to factor as x squared plus 7x plus 6. Then I look at that quadratic. I can factor that. X plus 6. X plus 1, and then get an x minus 3.
Wait, x plus
Oh, I missed the negative.
Isn't the,
Wouldn't it be a negative stuff? No.
Is everybody okay?
Wasn't the middle term a 7?
Yeah?
So when you. factor
6x
it
plus
out-
1x gives me
Oh,
7x.
what if you did?
Then you wouldn't get a
Oh,
7.
wait, that's, sorry. My bad.
All right, does this make sense? So, today we're practicing where I give you the hint. Eventually, after your quiz, I'm actually going to tell you ways where you get your own hint, where you have to figure them out. But that's not today, or Monday, or Tuesday.
Thursday.
Probably Thursday, yes, okay. Now, okay, so this okay? All right, so now I have to talk about, so the bad news is these are the easy ones, okay? So let's look at some uglier ones. And so let's say I give you 12x cubed plus 28x squared minus 9x minus 10 and 2x plus 1. All right, so I don't know if you remember this, but when we were doing synthetic division a couple of weeks ago, I said anytime you get when you put a fraction in this little box, a lot of you start twitching because you hate fractions. And what I tried to tell you is, no, what you hate about fractions is when you have to get a common denominator. And then I also said whenever you're doing synthetic division, even if you have a fraction here, you will never get a common denominator, right? So let's just actually go through this synthetic division and see if it's as bad as you think it is. I'm going to bring the 12 down. So what's negative 1/2 times 12? Boy, that was tough, wasn't it?
Yep.
I'm going to add, gives me negative 22. What's negative 1/2 times negative 22?
Positive 22.
Positive 20. What's negative 1/2 times positive 22?
Negative 11.
Boy, that was a tough computation too, wasn't it? Negative 9 and negative 11 is? What's negative 1/2 times negative 20?
10.
10. Oh, good, I got 0, didn't I?
Yep.
Did I have to get a common denominator at any point? The arithmetic wasn't that bad, was it? Okay. Now, here's what we need to talk about. I want to talk about what goes here. All right? Because what goes here may not be what you expect goes here. Right? Based on this information, right? Based on this information, anytime you do synthetic division, if negative 1/2 gives you a 0, that means x plus 1/2 is the factor. I know you don't like that because you're saying, wait, all the other problems we did, whatever this was goes here, right? The problem is, when you use synthetic division, if you've got a 1/2 here, you got to have a 1/2 in this. We're going to fix it.
You
But
just
I-
switched it to positive because the original was positive.
Right. Well, and also, when you set that equal to 0, what do you get?
Yeah.
Negative 1/2. All right? And so now, let's see what goes here. What? 12x squared plus 22x minus 20, right? Does everybody see how we got this information from our synthetic division? Because
Can you still use long division?
What?
Like, if it goes into fractions and you don't like the way it looks, can you use long division?
You always can use long division. But my claim is you'll never have to worry about the fractions as much as you think you will. All right. So now,
You just divide them by 2.
what?
You just take all 2 out of that.
That's, well, we're going to do more than that. Okay? I want to clean this up because I don't like having a fraction in my final answer. And do you notice there's a 2 in this? And so what we're going to do is we're going to factor a 2 out of this part. And actually, don't write, just watch. Because what I'm about to do is do a whole lot of writing that you'll never have to do. Okay? So, but I have to put the step down so you actually see what's going on. So when I look at this, there's a 2 in common, right? Everybody see there's a 2 in common here. So I'm going to pull the 2 out. And so when I pull the 2 out, then this is going to give me 6x squared plus 11x minus 10. Everybody okay that I pull the 2 out there? And then I have an x plus 1/2. Here's the part that's interesting. We're now going to take that 2, like we pulled the 2 from here, so I can distribute it to the first thing. And so when I multiply the 2 to the first thing, what do we get?
2x.
I get that 2x plus 1. Did everybody see how that worked? Like I had a factor of 2 here, so I had to pull that 2 out. And then I took the 2 and I distributed it to the first thing. And so now what I end up with is this is 2x plus 1 times 6x squared plus 11x minus 10. Can you factor that?
A little bit
Yeah.
easier.
It's quadratic. So let's practice. Okay, how are we going to get a 6x squared? 3 and 2, so I'll have a 3x and a 2x. How do I get a 10? 5 and 2. Can I put the 2 here?
10 and 1. No,
Oh,
just kidding,
no.
just kidding. It's 3 and 2.
Okay. Does everybody understand? I can't put the 2 here, right? Because I can factor the 2 out. So I'm going to put the 2 here and the 5 here. It's a negative, so one's positive, one's negative. I don't know. I'm just going to guess. I'll put a plus and a minus and check and see what happens. And how I check is I make sure I get my middle term. I get a minus 4x and a positive 15x. Does that give me my positive 11x? Oh, good, I guessed properly. And so then I remember to copy down to 2x plus 1. And my claim is that if I multiply all 3 of these things together, I will get that. All right, does this kind of make sense? This procedure is huge. Pretty much everything I'm going to teach hinges on this. Right? So I need to make sure this makes sense. All right. Last example.
That's a 4, right? For the
Yep, that is a 4. Okay. All right. So we picked the 4. In first period, they picked the 6. Doesn't matter. Okay. So I bring the 2 down. Gives me negative 8. Let's see, that's negative 13. Have a problem? Okay, that gives me 0. That gives me 0. This gives me a 36. That gives me negative 144. Oh, good, I still get a 0, don't I? All right, so let's kind of keep track of what's going on. So this is going to factor as, what goes here?
X minus 6. No, plus 4.
X plus 4, right? And what's going to go here?
2x squared.
2x cubed
6 cubed minus 13x squared plus 36.
plus 0 plus 36. And the claim is that if you multiply these 2 things together, you get this. But we're not done, are we? Because we have to factor this. What goes into this? Now this looks just like one of the problems I gave you, like the previous 3 problems, doesn't it? What's going to go into this? The x minus 6, right? The other one. So this is going to factor as x minus 6. And so now I have to divide this thing by x minus 6. Right? I could do synthetic division again, couldn't I? Okay, don't write it down. So Or is everybody okay, we're gonna do synthetic division on that?
You're allowed to do that, just do it on the one you already divided?
Yeah, well, aren't we trying to divide this up?
Yeah.
Yeah.
We've gotta break this up, right?
Yeah.
All right, do you agree that x minus 6 has to go into it?
Mhm.
Yes.
Isn't that the same type of problem we were doing?
Yeah.
Yes.
So I want to do this. So what I could do is, I mean, I could do synthetic division. I could say, well, okay, I'll put a 6 in the box, and I'll put a 2, a negative 13, a 0, and a 36. I could do that, couldn't I? But you know what? I like being efficient. You know, these numbers I already have written here, don't I?
Oh, yeah.
So what I could do is use those numbers and put a box here and put a 6. That way I don't have to write them down again, right?
Is that a positive?
Yeah, it's a positive 6, yeah.
It'll be the same answer either way though, right?
Yeah, but you didn't have to write as much.
Yeah.
And so now I'll bring the 2 down. That gives me a 12. Gives me negative 1. This time this gives me a negative 6. This time this gives me negative 36. Oh, good, I got 0.
So basically, we can just use synthetic division to factor all of it.
Yeah.
Oh, good.
And so what do we have? 2x squared.
Minus x minus 6.
Oh, I can factor that. It's a quadratic. So I do my 2 sets of parentheses. See, to get 2x squared, that's going to give me a 2x and an x. How do I get a 6? 3 and 2. Can I put the 2 here? No, because I could factor something out. So I'll put the 2 here and the 3 here. It's a negative 6. I have no idea. I'm just going to put a plus and minus and see if I get lucky, right? Let's see. 3x minus 4x. Oh, good. It does work. Then I got to bring down the others. I get x minus 6, and then I bring down an x plus 4.
Okay. Well, I've got all that.